Hello and welcome back to another LeetCode.js video. This video we will be talking about the solution to invert a binary tree. In this problem you're given a root of a binary tree, which is a tree node with this type definition. And the goal is to invert the tree and all its subtrees and return its root. So the key is to first be able to identify that you want to not only invert the first level of the tree, but all subsequent levels, subtrees as well. So once you understand that, then the implementation is fairly straightforward. You're given a root, so you want to do this recursively. So in the case that there is a root, because this might not be the case, then we just want to set the root.left, the left child of the root, to the inverted right child, and vice versa. Dot right is invert tree root dot left. Dot right, and double check that because the problem says that it is a binary tree, but it may not be a complete binary tree. So there may be a missing leaf node. But with this check, it should check out that there is indeed a root before we're inverting, or else we'll keep it as is. Now, finally, we just want to return the root, and that should be the solution. So we get some repeated values here. Let's see if we're setting the roots correctly. Yeah, does seem about right. Maybe just missing an edge case here. Try to think this through. See, in our recursive step, we should actually be reversing the values here. What I believe it's just calling invert tree root dot right, but it's not inverting. All right, root. Let's test for some simpler base cases here. So I'm not sure why there's some repeated nodes. So 2, 3, 1, but 3, but we're returning 3 again. Hmm. So line 15, we said root dot left is equal to invert tree root dot right. And in this level of recursion, if we go into invert tree root dot right, if root dot right, then root dot right dot left equals root inverted tree of root dot right, and inverted tree of root dot right dot left. So this happens only if there is a root. If there's not a root, then we're not going to be returning anything. And that's why it passes this third case. So, well, let's just remove this recursive step right here because I can't seem to figure out why it's not recursing. But this should give us the solution for the first two levels. Okay, we're just reversing the right tree and the left tree. So for now, okay, so when we set root dot left equals root dot right, we have root dot right actually equals root dot right again. So we do need to put it into a temp value, and that is the solution. So left equals root dot right, and right equal root dot left, and invert tree root dot left, and root dot left is equal to left root dot right is equal to right. So yeah, in this problem you really just want to make sure that you are not replacing anything that you might need for later, and you want to use these temp values. This left and right declaration really needs to be in a separate line from the assignment because of the replacement factor. So there we go. Solution beats 88% and does good on memory. There we go. Thanks for watching.